recording. It is the last day of chapter 9. Sorry, we're chapter 9, not chapter 6. Chapter 9, tomorrow you'll have your first test. So just as a reminder, we are not meeting in the Zoom room tomorrow, okay? If you have questions, you're welcome to email me clarifying questions and I'll help out as best I can. But we will not be meeting in class. However, the exam will open at 9:30 tomorrow morning. So at 9:30 tomorrow morning, you'll be able to access the exam. You'll have 24 hours to work on it. And you can use your double-sided, two-sided reference sheet or cheat sheet to as a resource for the exam. Other than that, just make sure to submit that exam by 9:30 on Thursday morning. Leave yourself a little bit of time to, take all the photos and upload the work. I know sometimes that takes a little bit more time than we anticipate and we get really stressed out when it doesn't happen right away. So make sure that you're doing that. But hopefully with all the work you've been doing in terms of uploading the quizzes, that it's getting to be sort of second nature for you at this point. So if you run into any problems, let me know, but it seems like everyone's figured out a technique that works for them. So yeah, with that being said, we're gonna go ahead and get started on 9.6 for today's lesson, okay?
I have one question about the test tomorrow.
For sure, what's up?
So with the test, we need to submit the signed paper,
Mhm.
and then we need to submit the test, and then we need to submit the cheat sheet. Do they all need to be in one PDF, or do they need to be like? 'Cause what happens? Like we're trying to get it all into one PDF, and like some of our programs aren't really like too friendly when it comes to like compiling them all into one PDF and submitting it. Is it possible, like if we aren't able to get one of them in there, we can email it to you separately? Like
I'd prefer if you could do it in a single PDF.
okay.
Which app are you using right now?
What is it? The cam scanner?
Cam Scanner. Okay, is there a page limit for Cam Scanner? Anybody know?
Genius Scan.
Okay. Genius Scan, if you have a MacBook, I find that one pretty easy because I've taken maybe a PDF with 20 different pages in it and been able to, because you just keep taking the pictures in the same file and it converts it all at one time. I haven't had to convert separately with Genius Scanner. But I know a lot of folks use Cam Scanner, so.
All right,
All right, well, if you run into any issues, let me know, okay? All right, so I'm gonna go ahead and share my screen now so that we can take a look at the 9.6 notes. Okay, so for 9.6, all right, this is a section called Miscellaneous Substitutions. And the pretty cool part about this is that we've learned a few specific techniques that work in very specific cases. And maybe they don't feel like very specific cases because all of the questions we see are of that specific case. But what we're doing in this last section is really thinking about how we can blend different techniques and use this idea of U-sub in a much bigger way than when we learned it in Calc 1. Now, with all the different substitutions here, what we're going to see is that some of these questions you can actually set up in more than one way and answer it using more than one way. And so that's something I've already started to see in some of the quizzes that folks are maybe working through problems in a slightly different order than what I present in class, but ultimately we're getting to the same answer. So as you're gonna find, there are definitely more than one way. There's more than one way to approach a single problem. Okay, so let's take a look at this first half of section 9.6, we're going to be looking at situations that have a root of a function. And more specifically than that, we're looking at roots that are not necessarily square roots, but might include cube roots and other roots other than just a square root. Okay? So if we take a look at example number 1 here, okay? I look at this and at first I think, well, maybe I could use trig sub because I have the x squared plus 4 in the inside, okay? What might be a little tricky with that is once I do the trig subs, I usually end up with something squared on the inside. And that's been really nice when we have a square root because then the square and the square root cancel each other out, okay? But in this case, we actually have a cube root. We don't have a square root. And so things are not going to cancel quite as easily as they would if it was a square root. Okay, so based on that reasoning, we're going to say no to the trig sub because we're looking at a cube root, not a square root. Okay. Now, if we were to think, well, maybe in a traditional sense, we could use U sub, we would maybe say that our U was this x squared plus 4x. And then usually we're looking for something that just has an x on the top, okay? But in this case, we have x cubed. It's a little bit harder to sub out if we use our traditional U sub, okay? So we're also going to say no to, let's call it a traditional U sub. And the reason is because we have an x cubed, not an x on the top. Now, I feel like you folks have really latched on to this idea of making sure that you substitute everything. That's something I've been really, really proud to see in all of the quizzes that you're doing, that you know you have to substitute out everything. And so what we're going to do here is we're actually going to do a substitution. It's going to be a U substitution, but not necessarily in the sense that we've seen before, okay? So one of the biggest questions when folks are learning how to do U sub is, how do we know what the U is? And typically we've said it's going to be the thing raised to a power, or it's the term with the higher power, things like that. But what we're going to do here is we're going to take a little bit more than we used to for a U sub and call that our U. So in this case, we're going to say that our U equals not just the x squared plus 4, but we're actually going to say that it equals the cube root of x squared plus 4. So like the whole denominator, okay? Now, if we have the whole denominator equal to U, and we start to think about our substitutions, then what we're going to get is we're going to get a situation where we end up with just U in the denominator, okay? But we have to substitute everything else as well, meaning we have to substitute the x cubed and the dx. So one of the things that I like to do here is when I find my dx, I can actually solve for, I can simplify this step right here so that when I take my derivative, it's easier to take a derivative of, okay? So what I'm going to do is I'm actually going to cube both sides. So I'm going to get U cubed equals x squared plus 4. Okay. Now I'm actually going to do one more step here, which is I'm going to say that U cubed minus 4 equals x squared. Okay. And we're going to save that for a little bit. And now that I'm here, I'm going to go ahead and take the derivative of both sides, okay? So when we take our derivative, we're going to end up with, on the left-hand side, we'll have 3u squared du. The derivative of 4 is 0, and that equals 2x dx. Okay. And I'm going to do one last thing, which is I'm going to divide both sides by this 2. So I end up with 3u squared over 2 du is going to go everywhere I see an x dx. Okay. So a lot of algebra right up front here. So I've established that my u is going to be the whole denominator. And in order to sub everything out, I cubed both sides, I moved that 4, and then I found my du to make it a little bit easier because I didn't have to have any fractional powers. I just needed to use power rule, okay? So what we're going to do now, this x cubed at the top, we're going to split that into x squared and x, okay? So the x cubed is going to become x squared, and then times x, and then I'll have my dx still at the end, all right? Now this is just an intermediate step, but from here, what I can see is that everywhere I see the x dx, I can replace that with 3u squared over 2 du. So that means that this x and this dx will get replaced with 3 over 2 u squared du. And then I actually have this x squared here. But look what I did in that intermediate step. Everywhere I see an x squared, I can put u to the third minus 4. Okay. So let's see what that looks like when we substitute everything in. We end up with u cubed minus 4 over u times 3u squared over 2 du. Okay. Any questions about how I got an equation with all x's into an equation with all u's and du's? So I'm going to start to move constants out to the front. I'm going to start to simplify what I have left in the interior. So I know that I have the 3 over 2 as constant, so I can pull a 3 over 2 out to the front. I also know that this u on the bottom can reduce with one of the u's up here. And so on the inside, I end up with 3, nope, no more 3, sorry. U times u to the third minus 4 du. Or we can write that as 3/2 integral of u to the fourth minus 4u du. And now I just need to use my power rule. Okay, no trig subs, no partial fractions, no completing the square, nothing else. Just using some algebra, I was able to get to a situation where all I need to do is use the power rule. Okay. So power rule says this is going to be u to the 5th and then a 1/5 in the front. And this one is going to be 4 times u squared, and then I have a 1/2 coefficient there, plus c. And we're going to go ahead and distribute this 3/2 to the first and the second term. So I'll end up with 3/10 u to the 5th minus, let's see, This 4 and those 2 go away, so I just have a coefficient of 3. So minus 3u squared plus c. And then our last step is just to write everything with x's. And specifically, u equaled x squared plus 4 inside of a cubed root. So 3/10 the cube root of x squared plus 4 to the 5th minus 3 times the cube root of x squared plus 4 squared plus c. Okay. Now, if you wanted to be super fancy, you could write those as ones with rational exponents or fractions in the exponent, and it might look something like this: 3/10 x squared plus 4 to the 5/3 minus 3 x squared plus 4 to the 2/3 plus c. All right. So this question is under the miscellaneous substitutions because we're just kind of playing around with the different variables and thinking about what choices we could use for our u. Okay. No, it would not be 6u squared. It would be 3. Because the 4 cancels with both the 2's on the bottom. So there's just a 3 in the front. So this is a way to approach this problem, okay? But I wanted us to see a different way of approaching this problem, again, using this untraditional u-sub, okay? So thinking about another term I could choose for u to get to the same answer, but maybe with a different process throughout, okay? Mariah, yes, you can write the answer either way. I think that I just wanted us to kind of know how to go between the two ways of writing the answer, just because in using power rule, it's really useful if you can see it in that like final boxed off answer if you're going to use power rule again for some reason, but it doesn't really matter. Okay. So let's try a different u for this scenario, okay? So let me go ahead and write the problem down again. So we've got the integral of x cubed over the cube root of x squared plus 4 dx. And so last time we made u the entire denominator. But this time, I just want to say u is x squared plus 4 and kind of see where that gets us, okay? So if u is x squared plus 4, then what we're going to end up with is a du of 2x dx, or a du over 2 equals x dx. So this is like a little bit more traditional feel, okay? The part that's a little untraditional is we're still going to take this x cubed and we're going to split it into x squared times x. So we're sort of blending two different techniques, okay? So that's going to give us the integral of x squared over the cube root of u, okay? And then x dx. And this x dx can be replaced with the du over 2. And we don't have it yet, but in one easy step, we can find a notation for x squared in terms of u. What I mean by that is we can go back to this u equals x squared plus 4 and say u minus 4 equals x squared. And so that u minus 4 is going to replace any x squared that I see. And so when I finish substituting, I'll end up with the integral of u minus 4 over u to the 1/3 du, and I need that 1/2 as the coefficient. So in this case, what I wanted to point out was a strategy and that is sometimes helpful in algebraically simplifying an integral. So that strategy is that I'm gonna take this u to the 1/3, it's in the denominator. I'm gonna bring it up to the top, but that means it's gonna be u to the negative 1/3. And then I still have my u minus 4. And now I'm gonna go ahead and distribute that u to the negative 1/3 to the u, as well as the minus 4. And that's going to give me 1/2 the integral of u to the 2/3 minus 4u to the negative 1/3 du. And from here, what we can do is use our power rule, okay? So we have our 1/2 coefficient in the front. Now, the power of 2/3, if I add 1 to that, I'm gonna get 5/3. And then the reciprocal of that is 3/5 will give me the coefficient. Minus 4 times, let's see, u to the negative 1/3. So negative 1/3 plus 1. That gives us 2/3. So my coefficient here, or my power is 2/3. And then the reciprocal at 3/2 is my coefficient. And then we have our plus c. And we're going to go ahead and distribute and distribute. So we'll get 3/10 u to the 5/3 minus, let's see what gets canceled here. This 4 and those 2 on the bottom go away, just like last time. So minus 3u to the 2/3 plus c. And then we have to go ahead and fill back in our x's. So 3/10 x squared plus 4 to the 5/3 minus 3x squared plus 4 to the 2/3 plus c. And so now if we compare both answers, both processes, we realize that we get to the exact same answer, but in a slightly different way, okay? So I just wanted to show you, because I think this is a question that some of you guys have already been asking. You've been saying like, well, I tried it this other way and I actually got the same answer. And so sometimes there is flexibility in the order in which we substitute things, or different people have different strengths, which means that they see different substitutions more easily, okay? And so this is just a good example of how you could set this up using 2 different methods, but you'd still ultimately get to the same answer, all right? Any questions on number 1? I know there was a lot of algebra going on in here. Okay, great question. Patrick asked if you could start with u equals x cubed. So if we kind of thought about that for a moment, let's see where that would get us, okay? So if u equals x cubed, then du equals 3x squared dx. And I see an x squared in there. I'd have du over 3 equals x squared dx. But I would say the issue with that is you end up with an x squared dx underneath the cube root. And that doesn't actually, like, I can't split those and say, oh, I'll substitute x squared under the cube root and my dx separately. So I think this is not a good substitution to make for this particular problem. If you have a radical, usually the thing underneath the radical is the u, or sometimes you can take the entire radical and make it the u. But if you have a radical, it's usually a bad idea to not make it the u, because you end up in a sticky situation where you can't quite sub out the dx, okay? All right. So let's take a look at example number 2 here, okay? This is sort of a slightly different flavor, all right? So we have a situation here that we've not seen before, which is that we actually have not one, but 2 different radicals. And they're not even the same radical. One is a square root and the other one is a cube root, okay? So before I start this question, let's go ahead and rewrite it with the powers so we can see the powers. So the square root of x, if someone asked a question, I did not hear that. Did someone ask a question out loud? Oh, no. Well, thank you for not assuming that I'm ignoring you. I'm not ignoring you. Hold on 1 second. Okay. Do we want to finish example 2 and then take a break and I can do a tech check? Or do you want me to take a break now and I'll go figure out the technology issue? Okay, okay. Thank you. I promise I'm not ignoring you guys, so thank you for understanding that. Okay, all right, so with this question then, I'm gonna rewrite this. So this square root of x, I'm gonna write as x to the 1/2, okay? And then this cube root of x, I'm gonna write as x to the 1/3. And what I'm gonna do is I'm gonna say that my u in my u sub is not the x to the 1/2 and it's not the x to the 1/3, okay? Instead, I'm gonna say that u equals x to the 1/6. Okay. So here's why that might be important. If I say that u equals x to the 1/6, if I square both sides, u squared equals x to the 1/6 squared, then I'm gonna get u squared equals x to the 1/2/6, which is the same as x to the 1/3, okay? So by picking a different u, I can actually call x to the 1/3 u squared, okay? So u squared is gonna go in the place of this x to the 1/3. But let's see what happens if I take this x to the 1/6 and instead of squaring both sides, I cube both sides. That'll give me x cubed equals x to the 3/6 or x to the 1/2. And so that means that everywhere I see this x to the 1/2, I can replace it with u cubed. So just like you guys, most mathematicians would prefer not to work with fractional exponents if they don't have to. So this is kind of a way to get around that, okay? But let's see what we need to do to sub out our dx, because that one we haven't subbed out yet. And so what I'm going to do is I'm going to say that u equals x to the 6th, but that also means that u to the 6th equals x. And the reason why I'm going to raise both sides to the 6th power is so that then I don't need to worry about fractional exponents, okay? Because this is a little easier to take a derivative of. I end up with 6u to the 5th du equals dx. And that's really nice because everywhere I see dx, I can replace that with 6u to the 5th du, right? So when we substitute all of these things in, let's pull the 6 out to the front. I have u to the 5th du, and then I have u cubed plus u squared. Now for more algebra, we're going to go ahead and take that denominator, factor out the greatest common factor, and we'll have u plus 1 left inside. And the reason why it's probably a good idea to do that is because now these two are going to reduce with 2 of those up there. So I end up with u cubed on the top, which is going to give me 6, the integral of u cubed over u plus 1 du. Now, a little throwback to pre-calc when you learned about synthetic division. We're actually going to pause from the integral for a moment, and we're going to take this and we're going to divide those using synthetic division. And when we divide them, that's going to split this into a few different integrals that we actually know how to handle, okay? So the number that makes this denominator equal to 0 is -1. So -1 is going to go inside the little thing. And then I need to represent u cubed in terms of just the coefficient. So it's 1 for the cube, 0 for the squared, 0 for the linear, 0 for the constant. Skip a line, draw a line. And I'm going to take the first number, bring that down to the bottom. And now every time I go diagonally, I'm going to multiply. And every time I go vertically, I'm going to add. So -1 times 1 will give me -1. And 0 plus -1 is -1. And then I start back over here again. -1 times -1 is 1. And then 0 plus 1 is 1. I'm going to do that one more time. -1 times 1 is -1. 0 plus -1 is not 0, is -1. But here's what this means, all right? We've got our remainder. This is our constant. This one is the coefficient for a linear term. And this one is a constant for the quadratic term. And so what this synthetic division allows me to do is to take my original integral and rewrite it into a few different pieces. So I can rewrite this as this 1 means 1u squared. This -1 means -1u. This 1 means just a +1, all right? So that's the division part. And now I have this remainder. And the remainder is just going to be that remainder over the thing I divided by. Okay? And so now I have 1, 2, 3, 4 mini integrals, but all of them are ones I know how to do. I've got the first 3 where I can solve using power rule. And then the last one, which is the one exception to the power rule, I'm going to end up with a natural log. So this gives me 6 times the integral of u squared is 1/3 u cubed minus the integral of u is 1/2 u squared plus the integral of 1 is u minus the integral of 1 over u plus 1 is the natural log of u plus 1. Okay. And now we're going to distribute. So we'll get 2u cubed minus 3u squared plus 6u minus 6 natural log of u plus 1 plus c. And then I'm going to go back, and everywhere I see the u, I'm going to put in x to the 1/6. Okay. Now, I could also say that this u cubed is x to the 1/2, right? We solved that earlier. So instead of 2u cubed, it's going to be 2x to the 1/2. And the other way we can say u squared is x to the 1/3. So 3x to the 1/3 plus 6, instead of u, it's x to the 1/6 minus 6 natural log of x to the 1/6 plus 1 plus c. All right. So a lot of different techniques from pre-calc, which I know was a while ago, but definitely come in useful in terms of being able to solve some of these integrals that are a little bit less traditional, okay? Now, as far as tomorrow's exam, if you're sitting here panicking a little bit about synthetic division because you haven't seen it in like 3 semesters, I don't think there are any tomorrow that require synthetic division, okay? But I did think it was important to see that, you know, all these techniques you learned a long time ago are definitely helpful in solving these questions. Why did I square it to get the 1/3? Yes, so I knew in my equation I had an x to the 1/3. So my question is, how can I represent that as a u to some power, not x to some power? And so that's why I took my x to the 1/6 and I squared it to make it the 1/3 power. Okay. How did I know that I should use synthetic division? Yeah, so in the case where the power on the top is bigger than the power on the bottom, usually we want to try and use synthetic division to break it up, because with our integrals, it's usually easier if the power on the bottom is bigger so that we can sub out whatever's on the top. Okay, so that's why we use the synthetic division here to get it to a form that is easier to integrate. Vincent, is it a common denominator or just a coincidence? Do you mean the 6, like the 1/6 power? Yeah, okay. No, that's actually exactly how I picked it. So I didn't just say randomly like x to the some power. I was like, it's going to be, what is my lowest common denominator for 1/2 and 1/6? And that was going to be 6. And so that's why I picked the 1/6. Okay. Sort of as a follow-up to that, if I had a situation where it was like x to the 1/4 plus x to the 1/2, then maybe I would let my u equal x to the 1/4, because that's the lowest common denominator for both of those. But if you had like x to the 1/3 plus x to the 1/7, then maybe you could say u equals x to the 1 over 21. Okay, so that is very intentional. It was not a coincidence. Cool. All right. So, folks, I apologize for the technology difficulties this morning, but I appreciate you letting me know. We're going to take a earlier break today. Let's take a break for about 7 minutes. Maybe we'd be back at 10:20. All right. That'll give me some time to figure out the sound piece on my end and make sure I can hear those questions that are coming through. Okay. So let's meet back here in about 7, 8 minutes, and then we will continue on with the last two examples for today.